The top lighting adopts skylights, mainly including rectangular skylights, soft-smooth skylights, and flat skylights. Rectangular skylights are equivalent to high-set windows installed on the roof. The lighting characteristics are similar to those of high-set windows, including longitudinal rectangular skylights, trapezoidal skylights, horizontal rectangular skylights, wall skylights, etc. Longitudinal rectangular skylights are referred to as rectangular skylights for short. The lighting characteristics are similar to high-set windows, although the lighting efficiency is the lowest among all kinds of skylights. The sides can be opened to facilitate ventilation and is the most common application. It can be seen from the figure light. The highest value of day lighting coefficient is at the midspan, and the lowest value is at the column. Due to the high position of the window, it is not easy to form glare, and the illumination is relatively uniform. The size of several rectangular skylights marked in the left picture have a great influence on the indoor lighting. As can be seen from the figure on the right, BMO has an impact on the average and the uniformity of indoor illumination. Increase BMO, the average illuminance will increase, and the uniformity will be improved. However, increasing BMO when there are multiple spans may cause the mutual occurrence of the adjacent two-span skylights, may also require internal drainage, resulting in a complex structure. Therefore, BMO is generally taken to be equal to 1/2 of B. HX refers to the height from the lower edge of the skylight to the working surface, which is mainly determined by the precise requirements. Raising the sunroof position will improve the uniformity, but the average illuminance will decrease. Therefore, it is recommended to take 0.35 to 0.7 times of B. BD refers to the distance between the sunroof axes. The smaller BD, the more uniform the illumination, but it will lead to an increase in the number of skylights and a complex structure. Therefore, it should not be greater than 1.5 times of HX. If BG is too close, it will block light from each other, so it is generally 1.5 times the sum of HG of the adjacent skylights. Since the four scales just introduced affect each other, the scale needs to be comprehensively considered in the design. After the glass air of the rectangular skylight is increased to a certain extent, the indoor illuminance will no longer increase. It can be seen from the figure light. After the ratio of glazing to floor air reaches 35%, increasing the glass air will not increase the indoor illuminance, and the average indoor lighting coefficient is only 5% at most. Therefore, rectangular skylights are only suitable for medium precision work and where there is a certain ventilation requirement in the workshop. In order to prevent direct sunlight from entering the room, the glass surface should face north and south. The slanted glass of the rectangular skylights is a trapezoidal skylight. It can be seen from the figure light. The average daylighting coefficient of the trapezoidal skylight is much greater than that of the rectangular skylight, at the same ratio of glazing to floor air, but the ratio of glazing to floor air is also limited. This figure compares the lighting effect of rectangular skylight and trapezoidal skylight with inclination angle of 60 degrees. It can be seen that the illumination of trapezoidal skylight is obviously improved, and the uniformity is obviously deteriorated. Think about it, trapezoidal skylight lighting has more advantages. Why not apply as rectangular skylight? What are the disadvantages? Because the glass of trapezoidal skylight is inclined to place, easy to accumulate ice, and the sun skylight is easy to incident, and the structure becomes complex, so the application is not common. The daylighting effect of the horizontal skylight is similar to that of the rectangular skylight, but the cost is nearly half lower. Since the roof truss is enclosed, the setting of the chassis is different from that of the rectangular skylight. This picture gives three measures. Figure A is all made into a horizontal rectangle, which is convenient for processing and installation, but the opening area is small. Figure B is made into a stampede shape, with a large opening area, but the size of the window is too large, so it is inconvenient to process and install. Figure C is inclined to make full use of opening area, but it is difficult to process and install. The well-tempered sunlight is suitable for high-temperature workshops and has a good ventilation effect. For smooth ventilation, windows are often not installed with glass. The rain shield is used to prevent the rain, but the light blocking is serious, so that the light is rarely incident directly and is mostly reflected through the bottom of the wheel, resulting in a daylighting coefficient generally below 1%. When vertical glass is used to block the rain, it will still affect the indoor lighting effect due to the accumulation of dust and the inconvenience of frequent cleaning. The sawtooth-shaped skylight is single-sided top lighting, which shows that the origination has a greater impact on indoor lighting. It can be seen from the figure that the uniformity of curves B and C is better than that of curve A, so it is advisable to arrange the windows facing north. It can also avoid direct light, prevent glare, and reduce the fluctuation of indoor air temperature and humidity. Therefore, it is suitable for constant temperature and humidity workshops. Due to the use of inclined shading reflection, the lighting efficiency is higher than that of rectangular skylight, which can reach 7%, so it is suitable for precision workshops. When the daylighting coefficient is the same, the glass area can be reduced by 15% to 20% compared with the rectangular skylight. Due to the strong directionality of light, machines with double-sided vertical working surface should be arranged vertically with skylights. In order to ensure uniform illumination, the distance between the axes of skylight should be less than twice the height from the lower edge of the window to the working surface, and several skylights can be set in one span. Due to the need for a skylight frame, the cost is higher. Flat skylights reduce the story height because they do not require skylight frames, making the construction cost only 21% to 37% of the rectangular skylights. Because the glass is laid directly on the roof, the structure is simplified and the installation is convenient. Because the glass is laid approximately horizontally, the illumination is greater than that of the rectangular skylight, and the lighting efficiency is 2 to 3 times higher than that of the rectangular skylight. Due to the flexible arrangement, the illumination is uniform, but the orientation cannot be selected. This picture shows three layout measures. It can be seen from the picture that the plan A is concentrated on the range. The plan B is evenly arranged in the middle of the roof, and the plan C is centered near the eaves. The uniformity and the average value of daylighting coefficient of plan B are the best. DC is the skylight spacing. HX is the height of the window position. It is recommended that DC be kept within 2.5 times of HX. Due to the installation needs of roof waterproofing and daylighting cover, a certain height of rib called well wall needs to be set around the opening of the flat skylight. The higher the ratio of the height of the well wall to the area of the well height, the higher the lighting efficiency. Making the well wall inclined can increase the amount of daylighting and improve the uniformity. The curve A in the figure is the daylighting coefficient in cloudy days, and the highest value is located under the flat skylight. Curve B is the daylighting coefficient in sunny days. There are two high-value points. Point 1 is caused by direct sunlight reflected by the well wall, and point 2 is caused by direct sunlight hitting the indoor floor. Obviously, it is easy to cause indoor overheating and glare in sunny days. Therefore, in areas with many sunny days, measures should be considered to diffuse sunlight, such as setting a movable sunshade and the flight sunlight, or using diffuse transmission materials as the shading. Finally, let's compare the window-to-ground ratio and the distribution of lighting coefficients when several skylights have the same plane and section, and the minimum natural lighting coefficient on the working surface is 5%. Picture A and Picture B are both flat skylights, where Picture A is centrally arranged and Picture B is scattered. Picture C is a zigzag skylight with included glass. Picture D is a rectangular skylight, and Picture E is a trapezoidal skylight. It can be seen from the figure. Picture B requires the smallest window area, and the window-to-ground ratio is only 11.5%. Followed by Picture E and Picture C, window-to-ground ratio is 16% and 20% respectively. The largest is Picture D, which is 30%. From the perspective of uniformity, Picture A is the widest, with a maximum daylighting coefficient of 14%, followed by zigzag skylight 11%, trapezoidal skylight 9%. The spread-out flat skies improved by 6.5%. The best uniformity is the rectangular skylight at 6%. Think about it. This window form can comprehensively consider factors such as solar radiation, ventilation, lighting, and sunshine, and all meet the requirements of the heat and light environment. If you can't do it, how to choose the window form? In addition to lighting, what other functions do window opening have? What other functions are required?